Hey, it's Kevin with the New Warehouse Podcast, bringing you a new episode today. And on today's episode, I am going to be joined by the CTO and co founder at Ambi Robotics, and that is Jeff Mahler. And we're going to talk a little bit about Ambi Robotics today. We're going to learn about their story, how they kind of came to found the company. We're going to talk about their latest release, which is the AmbiStack, and how that's developing. And we're going to talk just about the market in general and the robotic space within warehousing. So, Jeff, welcome to the show. How are you?
Doing well. Thank you, Kevin. I'm excited to be here.
Definitely excited to have you on as well. I'm excited to talk about this too and hear a little bit about the Ambi Robotics story and also what you're working on as well. So why don't we kick it off there? Tell us kind of a little bit about what Ambi Robotics is all about and your co-founder. So tell us a little bit about how you kind of came to found the company.
Yeah, I'd love to. First off, Ambi Robotics is building AI-powered robots to help people handle more in logistics operations. That means we are building fully integrated machines. We deliver hardware, software, and support services to help people move items around, specifically things like picking, sorting, and packing them, and work together with people to multiply their productivity. So we usually have people who are formerly sorting packages by hand becoming robot operators and managing one to maybe five robots in a production environment to get a productivity increase. To tell you a little bit about the story, I'm going to go back in time, uh,
Do it.
quite some time for us. We started at UC Berkeley. I was a PhD student in Professor Ken Goldberg's lab. He's a world renowned robotics
Mm,
professor there, as well as my other co founders, Stephen McKinley, David Gailey, and Matt Model. And we were looking at how to apply AI to robots because back at that time, deep neural networks had come out just a few years before. And we saw an opportunity to help robots adapt better to changes in the real world, like different items, by applying AI there. But the challenge that we saw was that the AI results that had come to pass up to that point were based on having huge amounts of data. And that's actually still true today. Things like ChatGPT are trained on internet scale data, whereas we don't have that type of data for robots, or at least that scale. And back then, we really, really didn't have it.
mm,
So we're researching how to tackle this problem, the robot data gap. And we tried a lot of different things and had a breakthrough in training robots in a simulated world before going to the real world. Essentially, we could collect data about 10,000 times faster by turning a problem like robot picking into a video game where they're able to score higher points for picking items more successfully.
mm.
And that was a very successful research project called the Dexterity Network, or DexNet. We got the opportunity to talk to a lot of folks, including Jeff Bezos himself. He invited us to present to his Mars conference back in 2018.
Oh,
And this is how we started to learn about the logistics world. Is we were getting media coverage on the DexNet project, and folks started coming to us and saying, hey, this could be useful in the e-commerce world. And we became very interested in that because, first of all, we wanted to make a real impact. We had been doing these demos and research for a while. That was all very fun, but we really wanted to take it to the real world and help people with the technology. And we saw that logistics was a great space to do it. It's a place where there's a lot of challenges, labor shortages, as well as a constantly changing environment, pressure for faster delivery times, lower costs, and so on. And at the same time, you have this adaptability challenge for automation where, because things are changing, there can be different types of packages, different colors, shapes, and sizes at any time. And so we started to focus on that space. We founded Ambi Robotics in 2018 to build a platform and extend the technology we had built to that point that would allow us to be able to rapidly develop robots that had industrial level reliability and would be specialized to different applications in the industrial world, starting with the supply chain. And over the next several years, we built out our first products, we built out the platform. And our first product, AmbiSort, we started to scale in 2021. And fast forward to today, we've deployed over 80 robots into production, sorted over 100 million items in production. And that's created a data moat to allow us to do a lot more with AI and improve reliability and performance in new ways as well.
Yeah, very interesting there, and I love how you kind of found the the need, I guess, in the logistics sector, which I think is really cool. I mean, I think that's a really interesting thing about this industry right now is that there's a lot of these technologies and advancements happening just out there, and they're very much finding a lot of practical applications within our area, which is cool to see and be a part of. So tell us a little bit about because there's obviously a ton of discussion about AI, right? And you mentioned AI in there, and that's like kind of at the core of some of your platform there. So tell us a little bit about, how does that AI develop and how does that become like an integral part of what your offering is?
Yeah, that's a great question. So, first of all, the AI is very important for enabling robots to handle a diversity of different items that can show up in different configurations, meaning they could be in a corner of a bin,
Mm,
on the side of a conveyor, and so on. And I mentioned our platform, it's called AmbiOS. What AmbiOS does is combine a growing library of AI robot skills like picking or placing or even item analysis, figuring out what materials an item is, or quality control, making sure an item's not damaged or they're not stuck together because crazy things can happen in the logistics world.
yeah.
And we'll combine those AI robot skills with modular hardware components like robot arms, cameras, end effectors to create solutions that can perform a task very well and adapt to these sorts of changes. And the AI robot skills follow a life cycle. So I mentioned there's this data gap. We start typically in simulation, and I'll talk a little bit about the AI robot skill of picking first. That's where our research
Sure.
had started. We need to sort of kickstart this data flywheel where we're going to collect more data, improve the model, and eventually get to really high performance. So we start in simulation, train a model that's good enough to work in the real world on day one, deploy some robots, and as those go out into the world, we can start to collect some data, and we'll do what we call supervised learning to update the model from the experience that it's had up to that point. So that might be training it on the results of picks. If it fails picking up an item, we can record that and the model can learn from that. And over time, as we collect more and more data, we can eventually move into the third phase, which is unsupervised learning. So taking a huge amount of data, which may not have any sort of label associated with it. And here we're talking about images primarily. And we can train a model to understand essentially the structure of these types of images so that it can really transfer to new applications very well. For example, if I'm picking packages and I need to move to picking apparel items, that sort of knowledge can be transferred with high performance very quickly. And our first model in this space is called Prime One. It's our first
Mhm.
foundation model. This is the first foundation model that we've created that's gone into production and trained on over 20 million images that we've collected from various experiences of robots in production. That's allowed us to handle a wide variety of items with much higher reliability and also get to these new use cases where we are picking a lot of package free items now. Even in production, there's a lot of interest in the parcel world in sort of putting a shipping label on a poly bag with apparel in it and
Mm,
shipping that. Why put a bag in a bag? And we love that idea. It can improve sustainability, and Prime One's allowing us to handle those situations better. So that's a bit about what the AI lifecycle looks like and how we got to Prime One. And now Prime One is now helping us also power new products to come to market faster, like AmbiStack.
mm. Interesting. Very interesting there. And I'm curious, like when because obviously you spend a lot of time researching and developing and things, but are you developing and researching, I guess, the software AI component of it first? Or are you thinking about form factor first and then kind of reverse engineering that and figure out what needs to happen to power that? How does that work?
Yeah, that's a really great question. So it's it's really a little bit of both. And R&D,
Mm,
we're looking at where we see opportunities in the market and trying to figure out what the missing pieces are. And I would say form factor does tend to be number one for us. And a big reason for that is robots can add a lot of value here, as we've talked about, helping deal
mhm,
with labor shortages and increasing pressure to deliver faster. But one of the hard parts is getting the value out of the robot because a lot of times if you put a robot exactly where a person was, it's hard to get the level of performance and ROI that you want. And there can be some successful use cases like that. But a big part of the challenge is thinking about how to rethink the process that's being done with robots. And that factors in the design of the machine and the form factor, like you said, to make sure that it's essentially a module that can go into an operation, change how that process works, and the people working with the robot can get a multiplier in productivity. So we do think a lot about that, and we try a lot of different things. There's a lot of sort of just design work that goes into that, and thinking at sort of an industrial engineering level of what sort of KPIs could we get to with these form factors. But going on the AI side, we will see opportunities such as coming back to AmbiStack,
Mm.
this fact that it's a really fundamental operation in logistics to stack items or pack them into
Yeah.
gaylords or other walled containers. But it's actually an unsolved problem in robotics today to be able to densely pack those items and fill out the space effectively when you can't see all the items that are coming in advance or sequence them to the robot. And
Mm.
so being able to go into an operation where there may not be sequencing infrastructure, take a stream of, say, parcels and pack them densely into a container, that's something that we started working on the AI side because we realized the opportunity. And there's been a lot of progress in sequential AI and reinforcement learning in the last decade, especially recently. And so we've developed our own sim to real reinforcement learning for training the AI to stack items densely and stably. So there's a
Mm.
lot of different vectors to R&D, but we really want to focus on the customer problem and where we can get that value through a productivity multiplier.
Gotcha. Interesting. Yeah. Yeah. I was going to ask you about that because I mean, think about stacking, right? From a human perspective, like it seems like a very kind of simple task, right? In theory, right? But it's interesting. So, so I guess, how have you kind of tackled that where, there's not like the robot doesn't know necessarily like what the next one coming is. I mean, maybe it can see the next one, but maybe, five packages or so down the line, it has no idea what size it's going to be or what shape or what it's going to look like. How does it navigate that? And how does it make sure that like you are getting the maximization of the space?
Yeah. So first, I'll talk a bit about why this is so hard for robots. And it's a bit
Sure.
counterintuitive, and this is sometimes called Moravec's paradox, that it's easier for AIs to do things like beat humans in the game of Go than it is to manipulate items, move them around, and stack blocks and so on. And one of the reasons it's so hard here is that you have a large diversity in different items that the robot could have to handle. And then you have that coupled with a lot of different options for how the robot could try to place items. It can place them in all kinds of position on the pallet, and it may have multiple options at once. And then you couple that with the sequential aspect, meaning the way you place an item now might affect your ability to have a stable pallet in the future. For example, if you put a small, maybe fragile item on the bottom of a pallet, it could get crushed later and cause problems. And so you have to hold back and wait for
Mm.
putting it on the top of a pallet. And this kind of sequential reasoning has historically been really hard for AI. And so what we've done is we've seen that there have been these advances in reinforcement learning, like I mentioned, and we focused on how can we simulate this problem in a way that is scalable, meaning we can run a lot of simulations in a cost effective manner and quickly, but also capture the right elements of what the real process is like. And one of the key elements is stability. So, how do we model that a pallet's going to remain stable as we continue to stack items on it? And one of the areas it comes down to is modeling contact between the items and how they're going to sort of maintain their structure under perturbations. For example, if you were to jostle the pallet at the bottom,
Mm.
are things going to fall over or will it stay together? And we do go through process of modeling things like that. We've come up with our own models for this, put it in a simulation, and then use that to essentially create a video game like 3D Tetris,
Mm.
where the robot is going to get a stream of random boxes, and they'll be truly randomized, or they can come from a data set that we have, maybe from a customer. And over time, the algorithm will learn how to place those boxes to get a higher score. And it takes a long time. It's going to try a lot of different things, some of which may not work very well. But as it tries many, many times, the algorithm can learn what's working better than other things. So, for example, you might want to start with a box on the corner of a pallet instead of putting it right in the center. That gives you more
Mm,
optionality later. It'll start to figure out these kinds of patterns, and we can give it also a certain amount of look ahead. So, seeing what's coming in advance. For example, if there's a scanner upstream that will scan and dimension the package, tell our
okay.
system about it,
Yeah.
that'll improve things. And AmbiStack as a machine and the form factor is also designed to give the robot optionality. So there's a conveyor going underneath a gantry system, a robot that moves overhead.
Mm,
And the robot can stage a lot of items on that conveyor so that it has more options of what to place when. And the algorithm's also learning about making those decisions, which item should actually be picked versus left for later in order to fill that space efficiently.
mm. Interesting. Yeah. And so I guess when you think about it, and it sounds like you've done a lot of testing and I guess learning of the model on your side, right? But when you put in like this AmbiStack solution into an operation, I mean, it sounds like it'll only get better over time, right? Is that accurate? Yeah.
That's right. So as we collect more and more data, we'll be able to improve the AI along this same AI lifecycle,
Mm,
seeing what boxes are out there, where they need to be placed, and what worked and what didn't work, and continuing to update the model from there.
interesting. Interesting. So now, when you deploy something like that, I guess like how do you explain that to the customer, right? Like that's like, oh yeah, like I want these results on day one, right? Like how do you tell them like, oh, well, this is just going to get better over time?
That's a great question. And we're mostly communicating with the customer in terms of KPIs that we want to hit,
Hmm.
throughput, of course, uptime, sort accuracy. But here we're also talking about space utilization. And
Mm,
we will take a preliminary look at what items the customer has. We can run it through the AI and understand where we think things might be on day one. And we'll come up with different phases. So here's where we think it would be on day one. Here's where we think it could get to after a certain period of time. And try to set those expectations also in a way where we can exceed them because we want to make our customers happy. And so we know our the logistics world is a very serious world of operations, and rightly so. They have very high standards, and we want to make sure that what we communicate to the customer is something that we not only achieve but exceed in time. And so we'll use the simulation to help us set those benchmarks.
interesting. Yeah, yeah. I think it's interesting because you want, like you said, very serious operations, right, and expectations and standards, right, at a high level, and it can be maybe challenging sometimes. I would imagine for you know companies that have we've done things this way for so long, and now we're going to put something in that it's uh like the best results are not going to be day one, right? The best results are going to be over time as it learns more about the operation and what's going on. So it can be hard to maybe, I can see like where in some conversation it may be hard for people to like grasp that a little bit. So it's a very interesting insight there. So for like the Ambi stack, I mean, who is like the ideal customer? Like at what level of movement and volume should you be at to be able to make this like a viable solution for you?
Yeah, that's a great question. So with AmbiStack, the ideal customer is really anyone who's stacking products in a repetitive manner, and
Mm,
often you can get an RI on them with the machine in 1 to 1.5 shifts, depending what your labor profile looks like, which we're really excited about because that opens up a much broader market of potential operations. And I can tell you that one of the areas we're seeing right now that we're excited about and really focusing on is the receiving area of buildings where
mm,
there's trucks coming inbound, they're taking products off those trucks, and we're putting them onto pallets to either go into storage on pallets, or sometimes it's even transient to put the cartons into like a carton level storage mechanism. And this is an area that is super labor intensive. There's a lot of interest in truck unloading automation today, as I'm sure you've seen.
yeah.
And the AmbiStack can help automate that process in a more complete manner, automating from the unloading the container onto the pallet. And now you can have AMRs and AGVs take things away. So we're really excited about that space in particular, but there's a lot more opportunity that
Mm.
we're also looking at and working on.
Interesting. Yeah. Yeah. That's kind of like where when I first saw it, that's like where mine kind of went to was like the unloading aspect, right? Because you're unloading the stuff, and a lot of it comes in not palletized, needs to be palletized, right? Stack it up and that type of thing. So interesting there. So now if you look at kind of the overall robotics landscape in the warehouse, like we've kind of heard what Ambi's up to and what you guys are doing. But what do you think is, like the next 2 years look like in the industry? Where do you see, whether it's Ambi growing or just like the market in general and adoption kind of going?
We're seeing right now the start of a more significant scaling of robots that are picking and placing items.
Mm,
And I think in the next 2 years, you'll continue to see that. The receiving area of warehouses, like I mentioned, is one area where I think that's really starting to happen with truck unloading robots. AmbiStack will be a part of that. And other areas of the warehouse as well, we do see a lot more interest in parcel sorting with our systems as well, and that
mm,
product's been out for a while, but there's still a lot more opportunity there. There's 22 billion parcels shipped in the US a year, and we're only handling a small fraction of those today. So that's one area. And highlighting on the technology side, one of the interesting areas that we're excited about and seeing a lot of growth in the industry in is mobile manipulation, things like Boston Dynamics Stretch or
mhm,
Bright Pick, where there's an arm on a mobile base moving around. Maybe it's pulling out totes, picking individual items from that. Maybe it's moving inside of a truck. That's a really exciting area. And I think we're seeing a lot of progress there now, whereas it felt a little bit more of a R&D sort of project just a few years ago.
mm,
Now I think
yeah.
we're starting to see the commercial traction, and even Locus announced their own version of this just earlier this year. So I think we'll see a lot more of that in the next few years as well.
Mm. Interesting. Yeah. Yeah. I was going to ask you about the kind of like pick and place idea. Cause like, I felt the same, right? When we see some of these solutions, they're like, oh, well, it's like it's picking, 60% of items, right? And that's not really effective for like a,
Right.
high volume operation, right? So, but obviously that's increased over time. That was like, a couple of years ago. But, so is it kind of the same reasoning that these solutions have gotten better over time because there's been more learning, there's been more data to digest for the systems that work behind the scenes on them.
That's part of it. And also development on the hardware side.
Mm,
There's been a lot of focus in this area, lowering costs, being able to make the sort of charging part of this work, power, um, robots being able to stay in the field and not going to the charging station too often. So those are the areas that I think have led to this. And on the AI side, though, these mobile
mm,
manipulators are most useful when they can adapt to
mm,
different types of problems, and that started to mature in a more significant way, especially with some of the computer vision foundation models like SAM, now SAM 2. These have enabled a much faster time to be able to go in and sort of segment out where is a box and then figure out where to pick it. So the AI world's moving super fast, and it's unlocking some of these more adaptable, or maybe to say it differently, less structured applications of robots.
mm. Interesting, interesting. And what would you say, I guess, for an organization or an operation that's, hasn't necessarily gone down the robotics route yet, but they're looking at it. How would you say for them to kind of navigate this and even just like where to start or how to start to digest it?
Yeah, I think first it's really helpful to go to a trade show like ProMat or Modex next year and see what's going on there, what sort of the state of the art is. Think about where the biggest problems are in your operation, but also try to see where there's the right fit, because the world is moving in this direction. And I think if organizations can afford to do it, it's good to start looking at this sooner rather than later to make sure that you don't get left behind in this industry. And so there's a lot of possibility for automation on the truck unload side, pallet build side, and elsewhere. that's starting to really mature, and there's a lot of companies who have those problems. So I recommend taking a look. And a lot of companies, I know we would do this. We will take a look at the application and we'll tell you if it's not a good fit. We don't want to go into places
Mm,
where we're not going to provide value to the customer. That's not aligned with our mission. So talk to us or talk to others, and we'll have an honest conversation with you about where robots might fit, or if they don't fit, why that might be the case.
mm. Yeah, yeah, and I love that. I love the honesty. Definitely, actually, was just having a conversation with somebody like a week ago or so. They're talking about some solution providers like overselling the solution and then not being able to ever really realize the value or the ROI. So definitely appreciate that honesty that you're talking about there. So I mean, really interesting time to be in the space. So I'm sure you're seeing as well. So now, if we look at Ambi Robotics specifically, like it just recently came out with the Ambi Stack, but what does the future of Ambi Robotics look like?
We want to continue developing new specialized robots that implement fundamental operations in a logistics operation. So
Mm,
we're sorting to mail sack, we're sorting to pallet, and AmbiStack. We think that we will be able to continue to working on that product and product family for quite some time, because there's many different variations of the stacking problem. There's stacking on pallets, there's cubing out gaylords, like I said, and one of the things we're very excited about with AmbiStack is also being able to do new types of functions with it. So, for example, right now it's building to pallets, but if you think about it, you can have any pallet location in the machine be either a pick or a place location. And so it becomes a very flexible machine to be able to do things like a store distribution operation, or sometimes the industry calls this case pick. You could have
mm,
mobile robots bringing pallets to the machine. We can pick from the source pallet to the donor, and you can have a lot of pallets stationed at once instead of having a bottleneck where like a pallet's going to one place, you pick one pallet and then you wait for the next thing to come in. So that's just one example of many things we think AmbiStack can do. And we're always looking at the market, seeing where we can provide value, and where there's a gap that we can fit into. And I think we'll continue to look at these sorting, stacking, packing problems for some time
mm.
and try to help warehouses in bigger and broader ways.
Yeah, interesting, and I think that's great. I mean, sorting and stacking is not going anywhere, right? So I think that's a good way to go. Definitely, yeah. But you mentioned like looking for gaps there. I mean, I'm curious what do you see as like the biggest gap in the warehousing market right now?
It depends a lot on the operation. Um, but what I would say is there's still um, there's still a lot of opportunity in terms of being able to also deal with, we do a lot of stacking and packing. I think that is a gap today,
Mhm.
but I think one of the opportunities in the future, and some people are starting to look at it now, is also dealing with essentially turning that problem on its side and dealing with shelves, because a lot of
Mm,
operations, even in our world, there's cartons going on to racks and people moving around in that space as well. And there's many other containers that are loaded in that manner. And it creates some challenges because you have to think about how to sort of keep items stable while you're inserting them or pulling them sideways. It's not an easy mechanical or AI problem, and we are seeing a lot of interesting progress in that space as well. Amazon just had an announcement, I think yesterday, about their system for doing this sort of thing in or excuse me, on the shelves, and I think it's just the very beginning of that. So I don't know if that's the biggest gap, but that's one that I think is really
mm,
interesting, and maybe not so obvious in terms of how hard the problem is.
mm. Yeah, that's interesting. Like because I mean, like you said, I mean, many warehouses have some type of shelving in place, right? And that shelving can vary in the style and the height of the shelves, the whatever the width, all these different variables in there. And I could see that being like a difficult thing to navigate through from a robotics perspective. So interesting there. Yeah, yeah. It'd be interesting to see how people begin to tackle that and try and do some interesting things there as well. So very interesting to talk to you here today, Jeff, and really appreciate you coming on and teaching us a little bit about Ambi Robotics and what you guys are up to, and also just your perspectives on the market as well. If people are interested in learning more about Ambi Robotics, or maybe they got some stuff to stack or sort and want some help with that, what's the best way to find out more information?
The best way is to go to our website, ambirobotics.com. We've got a lot of information there. There's even a configurator where you can design an AmbiStack to your problem and send us a note about how you think you might want to use AmbiStack or AmbiSort. You can also get in touch with us on LinkedIn. We're very active there. You can also reach out to me directly on LinkedIn or email jeff@ambirobotics.com.
All right, great. And definitely check out that configurator. That sounds pretty cool. I'm going to play with that a little bit myself. And we'll put all that other information at thenewwarehouse.com as well as in these show notes here. So, Jeff, thank you once again for your time on the show today.
Yeah, thanks so much for having me, Kevin. Great questions.
Hey guys, thank you so much for tuning into today's video here on our YouTube channel, The New Warehouse Podcast, and I appreciate you tuning in. If you liked what you saw, make sure you subscribe to our channel, and if you like this video in particular, make sure you like it as well. And if you want to get this great t-shirt that you see in the video behind me, Warehouses Are Sexy, head to warehousesAreSexy.com and get your own.